Today, the topic of our lecture will be example 10.4. This problem is about helical compression spring under the dynamic load. And in our previous lecture, we have discussed what is the dynamic load, its types, and what are the Feller criteria for the dynamic load. And we also discussed the spring specifically under the dynamic load as well in our previous lecture. So if you have not watched our previous lecture regarding the spring under the dynamic load, so you must go to that lecture. First watch that lecture and then come to this problem so that you can better understand this problem. So in this example, we are given that we have a helical compression spring and that is made up of music wire having wire size or diameter of the wire equals to 0.92 and the coil diameter is this one and the free length is this one. The active coils Na is equal to 21 and the both ends are squared and ground. The spring is unpeened and it is preloaded with 5 pounds and the maximum force that will be exerted on this spring will be 35 pounds. First of all, we are required to find out the factor of safety based on the Gerber criteria and we will use the Zimmerli data as well to find out the factor of safety, and we will have to repeat this means we have to find out the factor of safety based on science torsional fatigue criteria, and in the third we will have to use Goodman criteria to find out the factor of safety, and at the last we have to find out the critical frequency of the spring. We didn't have discussed the theory regarding the critical frequency of the spring, but there are some formulas. We will tell you those formulas. Based on that, we can find out the critical frequency. And later on, after this lecture, we record lecture on critical frequency theory as well. So let's go to the solution of this problem. For that, first of all, what you will have to do is to find out factor of safety based on the Gerber criteria, and factor of safety can be found from this formula, that is SSI divided by tau m. In our previous lecture, we have discussed this formula, so we can find out this SSI from table 617. This table is for Gerber and Engr Feller criteria. So for the Gerber, SSI can be found from this equation. So this is that equation, and if you see over here, there are different terms that you will have to find. You have to find this R, you have to find this SSU, and also you will have to find this SSE. First of all, let's see what is the formula for SSE. This is the formula for SSE, which is the Gerber criteria, but here SSF and SSM will be taken from the Zimmerli data. We have also talked about what is Zimmerli data in our previous lecture, and then we will have to find SSU from this equation, where SSU is equal to 0.67 of SUT, and SUT can be found from this equation. For A and M, we will use table 10.4, and then R can be found from this equation. Here I can be found from this equation, and over here KB can be found from this equation, and this C can be found from equation D by D, where this D is found from external diameter of the spring, wire diameter of the spring, and here this Fa can be found from the equation F max minus F minimum divided by 2, and tau m can be found from this equation. Here this Fm can be found from this equation if you make it plus, and F max is 35 and this F minimum is 5 pound. So using these formulas we can find out the factor of safety based on the Gerber criteria, as we will have to find out this D as well. So let's find out this D, which is equal to external diameter minus the wire diameter. External diameter is given, which is this one, and the wire diameter is this one. So external diameter minus wire diameter will give you 0.4705 inches. After that, since KB needs C, so C can be found from D divided by D, and putting the value of this D over here and this wire diameter over here, it will give you is 5.11. Since we know the value of C, we can put this value of C over here, and when you put these values, you will get KB is equal to 1.2 at 67. After that, let's find out the Fa and Fm. We have discussed Fa is equal to F max minus F minimum divided by 2, and F max was 35 and minimum was 5. So when you put these values, that will give you 15 pound. And after that, F mean is equal to f max plus f minimum divided by 2. So put the value of f max, that is 35, and f minimum as 5. So it will give you 35 plus 5 divided by 2. It will give you 420 lbf. And when you know fa and fm, you can find out tau a and tau m. So let's find out tau a, which is given by kb into 8 fa d divided by pi into wire diameter cube. We found the value of kb, we found the value of fa, we also find out the value of d, and the value of this wire diameter was given. So putting these values, it will give you 29.7 kpsi. So this is tau a. We can also find out tau m as well using the same formula, but instead of this fa we will have fm. So putting the value of fm instead of fa, that will give you 39.6 kpsi. Now we can find out the ultimate tensile strength as well, and that is given by R divided by d to the power n, and m values can be found from table 10.4 here for the music wire. And for the music wire, our m value is 0.145 and a value is 201 kpsi dot inch to the power n. So when you put these values, it will give you 284.1 kpsi. Now SSU is equal to 0.67 SUT. So when you put the value of SUT, it will give you 190.3 kpsi. Now let's find out the slope R. If you plot tau A and tau M, let's see if you are at this point and you join the that point with this point. This is tau A, this is the value of tau M, and this is the value of tau A. So if you divide tau A by tau M, it will give you the slope of this line, which is represented by R. So tau A is 29.7 and tau m is 39.6. When you put these values, it will give you slope of the line to be 0.75. So knowing this value from the Gerber criteria, we have defined SSE, and here if you remember, I told you that these two will be taken from the Zimmerli data, and for that SSI is 35 and SSM is 55. So you know the value of SSU as well, that is 190.3. So when you put these values, it will give you SSU equal to 38.2 kpsi. Now after that, as I told you from the table 10.7, SSA is given by this formula. You know the value of R, that is 0.75, and the value of SSU is 190.3. The value of this SSE is 38.2. So when you put these values in this equation, it will give you SSA is equal to 35.8. And in the previous lecture, I told you about, let's say this is SSE and this is SSU. This is the Gerber parabola. Let's say if you are at this point, then you do what, you draw a straight line like this such that it will pass through the Gerber parabola. So if you drop down a line on the horizontal axis, so this is the tau A, and from this point if you drop down a line, this will be SSA. So you will be safe by this amount. So when you divide this SSA by this tau A, it will give you factor of safety. So by being so, putting the values, you will get factor of safety equals to 1.21. Now after that, based on the sine law, we will have to find factor of safety, but we didn't have discussed the sine law. Actually, this sine law takes the load to be completely reverse load, for which tau m is equal to 0. Why tau m is equal to 0? Because f max plus f minimum divided by 2. But here for the sine law, this tau minimum will be equal to this f max, but this will have negative sign and this will have positive sign. I have discussed it in my previous lecture. So tau m for it will be equal to 0. Similarly, SSM will also be equal to 0. And when you make this SSM to be equal to 0, then this whole term will become equal to 0. And lastly, SSE will be equal to SSM. So when SSA is equal to SSE, here you know that for the Zimmerli data, SSA is 35, so you will get SSE equals to 35, and factor of safety already I told you is equal to SSI divided by tau m. SSA or SSE is the same, that is 35. So when you put 35 divided by tau m, which is 29.7, 7, so it will give you 1.1. Now let's move to find out the factor of safety based on Goodman criteria. And for that, you know that this is the factor of safety equation. Here the SSI can be found from table 10.6. This is the equation for SSI. That is equal to R into SE into SUT divided by R SUT plus SE. So this is the equation for SSI. Now here SSU has already been found out. Now let's find out SSE based on the Goodman criteria using the Zimmerli data. The equation based on the Goodman line is this one. Here I'm going to tell you that there is no square. This is over here. So put in these values. Ignore this square. You will get this value. And after getting this value for the SSE, you will have to put this value over here. SSU is already equal to 190.3 and this R is 0.75. So putting these values, it will give you 36.6. Since you know the value of SSI, that is 36.6, and tau is equal to 29.7, we have to find out it in the previous slide. So putting these values, it will give you 1.23. So based on all the criteria, we are almost safe. The factor of safety is greater than 1. Now let's go to find out the critical frequency, that is given by half of under root kg divided by w. Here k is found from this equation. G is actually the gravitational acceleration, and w can be found from this equation. Now let's find out the value of k, for which you will have to find this t. This is g. This is given to be 21. This is we have found it out in previous slides, and this t is already given in the data. So let's find out the value of g is 11.5. Putting these values, it will give you 48.1. Now this value of d is given. We have calculated this value as well. This value is 21. We will have to find this value from the table. So after putting all these values, it will give you w is equal to 0.05 at 6 pound. Now we have to put this value over here in this kg, and this value of the w or load of the spring, and this is 9.8 meter per second square. But here this meter should be converted to feet, so when you convert it to feet, it will give you 386 feet per second square. So putting the values, it will give you critical frequency to be equal to 81 hertz. Thank you so much, guys.